So for 1, you should have gotten positive 4 and negative 6. Number 2, negative 3 and negative 4. They were already factored for you. You just had to set each group equal to 0 and solve. The next two were binomials. 1 was a special case, number 3. So you just said square root, and they're subtracted. And so you would have set it up as x plus 6, x minus 6, and set each one of those equal to 0 to get positive and negative 6. For number 4, it was not a special case, but you did have a common factor of n. And so for this one, you would have just taken an n out and had an n on the outside, n minus 7, and set each one of those equal to 0 to get your answers of 7 and 0. So once you factor it like this, you're going to want to set the n equal to 0, which gives you a 0, and the n minus 7 equal to 0, which gives you a 7. So this one, number 5, it's not a special case. It's 5 times 30 would be a pretty big factoring. So is there anything you can do before you start factoring? What can you look for first? Just the common factor, right? Which is what? So we're going to take that 5 out first. All right. And now we are looking for factors of 6. They need to multiply to give you negative 6. And they need to add to give you a positive 5. What are they? Right. So you're going to have a positive 6 and a negative 1. Now, why didn't I use 2 and 3? Those also add up to 5. 1 has to be positive and 1 has to be negative, right? Had this been a plus 6, that would have been a different factoring. It would have been plus 2 plus 3, right? But 1 has to be positive and 1 has to be negative. And there's no way to have a positive 2 and a negative 3 and get a positive 5, right? And so you're going to look at both factors there. What makes it a positive or negative when you multiply? What makes it a positive or negative when you add? All right? So now that you have this, the 5 actually is insignificant when you're solving, because you don't set the 5 equal to 0. It will never be 0. You set the x plus 6 equal to 0. You set the x minus 1 equal to 0, which is how you get the positive 1 and the negative 6 as your answer. It's going to have a common factor. I hope so. So we'll have to do 108. All right, yeah, 6. All right, so yeah, 6 is your common factor. So we're going to say m squared, 18 divided by 6. What about 108 divided by 6? Yeah, 18. All right, so now we're looking for factors of 18. And again, they have to multiply to give you a negative 18, which tells you 1 has to be positive and 1 has to be negative. That's the only way to multiply and get a negative. And they have to add to give you a negative 3, which means your larger of the two will likely be your negative, right? That's how adding works. So what two numbers multiply to give you negative 18 and then add to give you negative 3? 6 and 3, right? Which one is negative? The 6, all right? And so you can double check it. You have m minus 6, m plus 3. You can do a quick check. Negative 6 and positive 3 give you negative 18 when you multiply. Negative 6 and positive 3 give you a negative 3 when you add. You factored correctly. All right, and so that's how you know the difference in what to use there. And then you just set the groups equal to 0. Set the m minus 6 equal to 0, the m plus 3 equal to 0. You get positive 6 and negative 3. Which you'll notice is always opposite of your factors that you found. You do not even want to look for common factors. You don't want to factor anything until you have set this equal to 0, which just means move whatever's on the right side over, okay? And again, I always keep my first term, my a, positive. So however I can keep my a positive, I'm going to do that. It's positive on the left, so I'm going to move everything to the left. And so before you even start, you're going to move this 2 over here. So you have x squared minus 38. When you move the 2 over, you will have 0, and it will become a positive 2 on this side. It was a negative 2 on the other side. I do have to add it to my like term, which is the 38. So negative 38 and positive 2 give me what? Right, which looks vaguely familiar. This is a special case, x plus 6, x minus 6, just like we did above. And so our two answers are positive and negative 6. Positive and negative 6 here. Again, this is not equal to 0. So my very first step is going to move that negative 6 over. B squared minus B minus 48. And then I do have to add that 6. It was negative on the other side. Moving it over, changed it to positive. So B squared minus B, negative 48 and positive 6 give me negative 42. So I need two terms that multiply to give me a negative 42 and add to give me a negative 1. Right. Sorry, I was writing X. I prefer X over B. That's okay. Set each factor equal to 0 and solve, which is where you get a negative 6 and a positive 7. So basically we are doing the same thing. We are just doing it a different way. So the first way you can solve is by factoring. Now, factoring is by far the easiest way. If you can factor and figure out what your answer is. Because typically, if it can be factored, you're going to be able to see it rather quickly. The next way is taking the square roots. You know, it would seem like if I already know how to factor, why do I have to bother learning this way? Well, it's not always going to be two perfect squares. And so taking the square root is what happens when you have a 0 for a b. This is the only time you're going to use this method. You're going to have an x squared piece and a constant piece, and you are not going to have just an x. And so when you have that, either it's going to be a perfect root like this guy, or it's not, and you're just going to have to simplify the root. But the easiest method is to solve by taking the square root. So the first thing I want to talk about is one that we can do easily by factoring. X squared minus 64. That is the difference of two squares. We have x minus 8x plus 8. You set them equal to 0, and you get a positive 8 and a negative 8. That's how this works, all right? What I want you to notice, though, is this rule that they have, this square root property. If n is greater than or equal to 0, and you have a variable like x squared equal to that number. So x squared is equal to some positive number. That's what they're saying. Then x is going to equal either the positive or the negative root of that number. That's how this works. Example, you have x squared equals 9. 9 is a positive number, so it meets that first part of the if-then statement. What they're saying is, well, you can just take the square root of both sides. What's the square root of x squared? X. What's the square root of 9? 3. But when there's a variable involved, you have to consider that your answer could have been negative 3. If I just said, what is the square root of 9, and no variable was involved, you assume the positive root. It's the primary root, technically, all right? But if there is a variable involved in the equation, and they're not just asking you a set of numbers like you did in 6th grade, give me the square root of 36, give me the square root of 25. If they say x squared equals 25, you have to consider that you could plug in a negative 5 and it would work. If I plug in a 3 to this original equation, I'm going to move this guy out the way. I get 3 squared equals 9. Is that true? Yes, it is. But if I plug in a negative 3 and square it, that also equals 9. So you would have two answers here. You would say it could be positive 3, it could be negative 3. That's what this rule is telling you. All right? Now here's the caveat. If it is greater than 0, you will always have two real solutions. Two real solutions. This was bigger than 0. I had two solutions. All right? If it equals 0, I will only have one solution. Why would that be? X squared equals 0. What's my only solution? 0. So if it is bigger than 0, I'm going to have two real solutions. If it equals 0, I will have one real solution, and it will always be 0. But then the other one is, if it is less than 0, x squared equals negative 9. What is the problem there? If I take the square root of both sides, I have a situation. That is not a real number. Square root of a negative is not a real number. It's technically an imaginary number, which you get to do with me in Algebra 2. But it is not in the real number set, okay? It's not in the real number set. And so there are no real solutions if you are trying to take the square root of a negative number, all right? And so you would actually say no solution here for me. Or you could use your empty set, that's fine. All right? So we're going to do some of these using this method. X squared minus 64. We are not going to solve by factoring. When you solve by taking the square root, you are going to get the square by itself. That is your first step. So to get the square by itself, I'm going to move everything that is not the square over. So I'm going to have x squared equals positive 64. And then I'm going to take the square root of both sides. Now I'm showing you one that has a perfect root so that you can see the process. So here, x will equal the positive or negative square root of 64, which is 8. And you are welcome to write the plus and minus in front of your 8. Or you can say 8 and negative 8. I do not care how you write it, all right? As long as you indicate that those are two answers. Look at this one. Solve by taking the square root. My rule is to get the square root by itself, all right? So that is what I do. I get the square root completely by itself. In order to do that, I have to do two steps now. I need to move the 24 over, all right? Move the negative 24 over. 2x squared equals positive 24. When it moves across the equal sign with plus or minus, it changes signs, right? So you're technically adding that 24 to both sides. That's what you're doing here, all right? 2x squared equals 24. Do I have the square by itself? No. What's the problem? I still have a 2. Divide by 2. So now I have x squared equals what? 12. So I have to take the square root of both sides. Square root here, square root here. So x is going to equal the positive and negative square root of 12. 12 does not have a perfect root. What do you think I want you to do with this? I want you to simplify it, right? So if it were square root of 5, you would be done. It's a prime number. But now we need to use our factor tree and see if we can simplify it in any way, shape, or form, which, by the way, you can. So 2 and 6, 2 and 3. What comes out? A 2. What stays in? A 3. So it is the positive and negative 2 square root of 3. This is what your answer will look like. Positive and negative 2 square root of 3. All right, solving equations in the form. Isolate the squared expression, apply the square root property, and simplify the radical. Here's the deal. It is in squared form. The square is already by itself, is it not? The square is over the group. So I already have a square completely by itself at this point. My next step then is to take the square root. So let's look at this. I have x plus 2 quantity squared equals 36. All right? My square is already by itself. I need to take the square root of both sides. So I'm going to take the square root of this side, the square root of this side. When I square root a square, I just get what is inside. All right? So basically, this guy and that guy cancel each other out. An index of 2 and an exponent of 2 cancel each other out. And so I'm left with what is inside here, which is x plus 2. All right? Square root of 36. What is the square root of 36 when a variable is involved? Or negative 6, right? So now I have two equations to solve. You cannot leave it like this, all right? You have to actually solve the two equations. Like, if you move this over, because I need to get x by itself, right? So if I move that 2 over, x equals positive or negative 6 minus 2. Well, that's tremendous. But those are actually numbers, and you can do them, okay? And so you're going to keep going. So you're going to say, well, x is going to equal positive 6 minus 2. X is also going to equal negative 6 minus 2. because I just said that this group equals positive or negative 6. All right? Does that make sense? So you have to actually set up two equations. X plus 2 equals 6. X plus 2 equals negative 6. X plus 2 equals 6. X plus 2 equals negative 6. You have to set up those two equations. All right? And so once you do that, you are just going to solve. 6 minus 2 gives you a 4. What is negative 6 minus 2? Negative 8. These are your two possibilities for x, 4 and negative 8. 4 and negative 8. All right? So when it is a number like this that has a perfect root, you are going to end up saying whatever this group is equals the positive, whatever this group is equals the negative, and then solve. All right? The next example is not a perfect root. So let's look at example 4. All right? X minus 2 squared equals 21. So we have this right here, just like we had in the prior example, but the difference is that 21 is not going to be a perfect square. If you take the square root of both sides, you're going to say x minus 5, remember the root and the exponent cancel, equals the positive and negative root of 21. 21 is just 3 and 7. Even with a factor tree, you can't simplify it. If you could, you would. All right? My x, however, is not by itself. What's with my x? A minus 5, right? So I need to move that 5 over. Now here's the deal. When you have a radical that is not going to simplify out like the square root of 36 would, all right, you're going to have an answer that doesn't look finished. So I'm going to move that positive 5 over. I always put my whole number in front. Then I put this positive or negative, square root of 21. Technically, it is 5 plus or minus the square root of 21. That is your answer. And you are done. You can't do anything else with it if I want an exact answer. If you were using a calculator and I say I want you to round it, that would be different. You would actually do a plus or a minus. But if I want an exact answer, meaning I want it like this is the exact answer, this is your answer. 5 plus or minus the square root of 21, and you are done. So if it has a perfect root, you would say the number plus the perfect root, the number minus the perfect root. And you have two actual answers that look like answers. If it does not have a perfect root, you're going to leave it just like this. The number plus or minus the root that does not simplify. All right? Questions on that one? All right, let's try a couple of those. So for a problem like this, or if this were factoring, I don't even know if you can factor this one, I haven't checked. You really need to get, if you're solving by the square root, you need to get all of your squares on one side and all of your numbers on the other side. All right, and I typically try to keep my coefficient positive. So I would likely move my x squareds to the left and my numbers to the right here, just so I wouldn't have to divide by a negative, but that's me, all right? So if you're solving by taking the square root, so you just have x squareds and you just have numbers, there are no just x's, then I would move all my x squareds to one side, all my numbers to the other, and then worry about getting my x squared by itself. So I'm going to move this 2x squared over here. And I am going to subtract the 2x squared. It was positive on the right. It's going to be negative on the left. I'm going to move the 6 then to the other side. It's positive 6 here. It's going to be a negative 6 here. All right. So I have moved my 2x over, 2x squared over. I have moved my 6 over. And I am going to get 7x squared minus 2x squared, which is going to give me a 5x squared, and 8 minus 6, which gives me a 2. My x squared is still not by itself. What do I need to do to get the x squared by itself? Yeah, I need to divide by 5. I do not want decimals here. We'll leave it a fraction. X squared equals 2/5. All right? I need to take the square root. Now, this is the square root of a fraction. All right? So x is going to equal the positive and negative square root of 2 over square root of 5. Can either of those be simplified? Can 2 over 5 reduce? No. Are 2 or 5 a root that can be simplified in any way? No, they are both prime, okay? But there is one more thing I need to do to this fraction. Remember, with radicals and fractions, what's my last thing I do when I am simplifying division of radicals? What cannot be in the denominator if it is simplified all the way? That radical, right? And so I am going to multiply the top and the bottom by the square root of 5. All right? So I'm going to still have the positive and negative. Don't forget that. On the top, I have the square root of 2 times the square root of 5. That gives me the square root of 10. On the bottom, I multiply square roots, the same exact square root. So what do I get on the bottom? Just a 5 with no root. Can I simplify the 10 to the 5, and why or why not? No. It is inside to outside. You cannot simplify. You are done here, okay? So you have the square root of 10 over the square root of 5, and you have that positive and negative there. And that is your answer for this one, all right?